Okay, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. Last week, we don't have any class, but the contents for last week I have already shared in our WhatsApp group, which is I think pictures and also recorded lecture. So basically, what should we learn last week is how to produce our PDS based on the HOQ. Right. So for today, I will just go in brief regarding the process for establishing our design specification. So basically, um, design specification, or we can call it PDS, product design specification, should be our target. Meaning, now when we have our PDS, then we start doing a design so that we can achieve the targets set in our PDS here. Okay, how we produce the PDS based on our HOQ. Alright, so first of all, before you start doing design, you need to list down all of the needs first. This is the first step. List down all of the needs. In other words, what customer want in our product. So you have to list down everything. In our case, you are divided into SG, means smaller group, consists of 2 students. Uh, and in your big group, you have 5 small groups. And each small group or each SG will focus on specific system for a car. So, regarding the needs, I think it might some of you might face some difficulties to list down the needs for the specific system that you have to design. So I think one of the easiest option is basically you can list down the needs for the whole car first. Why I think it will be easier? Because here, then you would have 15 brains lah basically in your SG. Sorry, in your BG, big group. Because in a big group, one big group has to produce one car. So if you try to list down the needs for a whole car, then you can cooperate with the other 14 students lah. More brains should generate more ideas. And when you do this approach, needs for the whole car, you should set a target. Then the needs has to be as many as possible. I think should be at least 50. Okay, once you have all of the needs for the whole car, then you divide it into the specific SG, the specific system. Okay, then from the needs of the whole car, you can divide it into 5 needs for each of the SG. That means you have 50. Then maybe after you organize it and after you discuss it among yourself, then you decide that, okay, these needs need to be addressed by this SG and so on and so forth. So maybe from 50, you divide it into 5, then each of the SG will have something like 10 needs. Okay, and then from there, the SG now has list down all of the needs based on the whole car. Okay, and then go to the next step, which is to list down the requirements, basically to address the needs. Okay, and from here, you organize the needs and the requirements. Because here, you list down or you describe the requirements that you think can address the needs, but you don't know how the requirements influence the other requirements, and also how the requirement that you have list down also affect other needs. So here you need to do HOQ, where you will establish the relationship between them. Okay, in short, here you will list down your requirement, and here needs, and then here basically the relationship between the needs and the requirement here. The relationship we define it in terms of the strong, less strong, weak, weaker, and so on. Usually you use symbol. You can describe your own symbol here. Basically here, relationship between requirements and the needs. Okay, and then the roof of the house here is basically the relationship between the requirements. In this case, the relationship is plus minus or plus plus minus minus. Means in the case of the minus, you can see in this example. Wait, I will share. Right. So example of the HOQ is here. Okay, you can see here is the relationship between the requirements and the requirements. So plus means that when you improve this can be improved, or this will automatically be improved as well. If minus, that means if you improve one requirement, or if you focus on the improving one requirement, the other requirement will be worsened. Then we have a minus relationship. Okay, and then from here, you rank your requirements. Okay, here you need to do some calculation lah. The calculation here, to do this one, you first need to define the importance of the needs. Okay, once you define the importance of the needs, then based on this one, strong, weak, and so on, you have to give marks. If strong, how many marks you should give? Weak, how many marks? And then whatnot lah, zero ke apa ke? Okay, and then from there you calculate and you sum up the marks for each of the requirements, and then you see which requirement receive the highest mark, which receives the least mark. So then you will have your ranking for the requirements. The rank means that the requirement has the greatest importance. Okay, for example here, then you have the absolute importance, which can be used to rank the requirement. So in this case, this is the most important requirement, or not. This one is the most important requirement based on this. So naturally, we should focus on this more lah, this thing more as compared to the other. Right, and then how can we focus it in this case? Okay, you can, based on this one, you have to define the specifications. Now we go to the PDS. So in this case, how can you define the specifications? For example, here hybrids, then maybe you can define the specifications in terms of the driving modes. Because when we talk about hybrids, the modern hybrid, you can have various driving modes. But for some hybrids, the flexibility is not very good. So the driving modes will be limited. So maybe you can define it in terms of the driving modes. For hybrids, the possible driving modes are one, conventional mode, which means the driving is achieved only by engine. And the second is the mixed mode, where the driving is achieved using the power from the engine, conventional, and also electric motor. And then the third one is a EV mode. which means the car is driven solely by the power from the electric motor. So in this case, you can use the 3 modes as the design target. Okay, when we produce the design target or the design specification, please remember to make sure that your specification, the target, has a values, meaning it has to be measurable. Measurable. This is very important because later on, once you have completed doing the design, then you can measure it to see whether your design is good enough or is not good enough. How good is good, how bad is bad. Right. Any question? This one should agree. Okay, any question regarding the HOQ until the PDS? So now I want you to produce your PDS, your HOQ and your PDS, and then I want you to submit it. So then we can check it and guide you what need to be improved for your HOQ and your design specification. Okay, make sure, I hope you, in each of the SG or BG, you should already have some ideas of your HOQ and PDS, because now we want to start producing a design. Question?
Yes, Doctor. I have question.
Okay.
Doctor, regarding the specification, Doktor kata kena ada kena ada measurement kan?
Ya, dia kena measurable.
Let's say specification kita orang like traction control or ABS, and then measurement dia macam mana?
Kejap, macam mana kamu punya spek tadi, baik semula?
Specification kita contoh macam kita tambah ABS ataupun traction control or something like that.
ABS ataupun traction control. Okay. In that case, okay. If in the reality lah, kalau betul punya, kalau in the actual industry, kita akan measure lah how good is our ABS. Then you would have certain parameter. Contohnya, bila ABS tu dia operate, nanti kamu akan ada dia punya response ke, ataupun berapa jauh dia punya braking distance tu. Then that is the parameter that you can use as your measure lah, how you want to measure whether your ABS is good enough or not good. Okay, so that is the real example lah. The same thing with the traction lah. Then you kena tengok macam mana traction control tu functioning, and then based on that kita define apa parameter yang kita boleh ukur waktu tu. Kalau traction control, saya tak pasti macam mana nak measure, kena tengok detail lah. Tapi kalau yang ABS tu saya nampak mungkin braking distance. Right. But in your case, okay, let's say you want to include ABS. ABS dengan traction control. Right. Okay, then in your case, kalau nak senang, kita letak semua tu dalam kategori driving assist. Okay, driving assist, then kamu kata dalam driving assist tu, kamu nak ada 3 jenis driving assist. Ataupun 2 jenis lah contoh. Okay, dalam kes ni 2 jenis driving assist. Okay, maknanya dia punya dia punya measure tu adalah berapa banyak kamu punya driving assist yang ada. Okay, then bila kamu design, kamu dapat include ABS dengan traction control. So maknanya kamu ada 2 lah driving assist. Then kamu achieve lah. Okay, jadi maknanya nanti masa nak test, nak tengok sama ada achieve ke tak, kamu develop kamu punya ABS dengan traction control. Kalau dia working, dua-dua working maknanya 2/2. Maknanya 100% achievement lah. Kalau salah satu je working, satu lagi tu tak berapa nak working, then 1/2. Jadi itu mungkin kamu boleh buat macam tu lah, lebih mudah lah. So dia punya kriteria dia adalah functioning ataupun tak functioning. Kamu define dia in terms of berapa banyak lah yang kamu boleh include dalam kamu punya kereta. Okay tak?
Okay, Dr. Clear.
Macam tu salah satu option lah. But in actual case, usually we measure lah how good is our ABS. But I don't think in our course here is feasible lah. So I think it makes sense to use that approach lah, where you define you want to include how many driving assist, and then eventually we see how many that we include actually works. Okay, anything else?
That's all, Doctor. Thank you.
Okay, ada soalan lain ke?
Doctor,
Ya.
about the specs and the target, the target can be anything that we actually want. I mean,
Yes.
tapi dia fokus on that particular spec lah. Macam for example, saya punya tu ialah steering. So spec yang saya ada letak adalah steering steel components. Lepas tu target dia easy to find. Saya tulis. So boleh letak macam tu je.
Kejap itu macam tak berapa kena. Maknanya kamu kata kamu nak pakai steel components
Steel components.
Tapi itu saya rasa lah itu macam tak kena sangat. Mungkin kamu boleh tukar. Kenapa nak pakai steel Boleh tahu tak kenapa nak pakai?
Yang saya nak pakai yang standard steel. Dia bukan steel dia.
Jadi kiranya kamu nak saya rasa sebenarnya kamu nak address mungkin needs kamu adalah komponen yang common yang senang jumpa. Dan murah lah. Dan murah Okay. So kita start dekat needs lah. So maknanya kamu punya needs tu adalah affordability mungkin. Lepas tu kamu punya requirement kamu kata nak pakai standard components lah. Standard components maknanya dalam kes ni standard steel kan. Okay. So bila dia nak jadi tu dari kita punya requirement, then bila dia nak jadi spec, okay, spec ni adalah something yang kita boleh measure. So dalam kes kamu ni, saya rasa lah mungkin kamu boleh buat berapa percentage daripada semua komponen yang kamu guna untuk produce kamu punya steering tu yang kamu pakai stainless steel.
Okay.
Faham tak? Contoh kalau kamu nanti bila kamu dah design kan, kamu set target lah. Contohnya kamu set target kamu nak 50% daripada semua komponen yang kat dalam sistem steering kamu tu pakai material standard steel tu lah. Okay, and then daripada situ kamu design, lepas tu nanti kamu compare lah. Jadi contoh bila kamu dah habis design nanti, kamu ada dalam 20 komponen dalam kamu punya steering tu, kamu tengok berapa banyak komponen yang pakai steel tu.
Okay.
Then maknanya kalau nak lagi murah patutnya lagi percentage lagi tinggi lah kan. Jadi kamu tengoklah nanti achieve ke tak.
Okay.
Itu macam tu lah. Saya ingat macam tu boleh pakai kot sebagai kamu punya target. Alright. Ada apa lagi?
Doktor.
Ya.
Contoh kalau in my case in powertrain right, of course lah kena the electronics kena be waterproof right?
Okay, ya.
Okay, so kalau target tu if the target I just put it as yes, kan memang is it like we need to have a unit yang boleh measurable.
Okay waterproof
Bukan waterproof.
Dia macam water resistant lah. Okay, dalam case tu kalau sepatutnya lah kan, macam mana kamu nak proof yang kamu punya sistem tu dia waterproof? ada mesti cuba kamu fikir macam mana kamu nak prove tu, macam mana kamu nak test, nak menunjukkan yang memang dia meet requirement tu.
Oh, okay.
Contoh kamu kata kamu nak rendam kamu punya sistem tu dalam badi 1 liter ke apa. Then itulah kamu punya specification. Maknanya kamu letak specification kamu waterproof. Lepas tu target dia bila letak dalam air 1 liter pun dia masih tak rosak. Contohlah. Macam tu. Jadi nanti bila kamu dah siap semua, kamu test macam tu dan dia tak rosak, then kamu katalah okay kamu meet requirement tu. Kamu meet lah kamu punya target tu.
Kalau if we refer standards tu, contoh macam IP punya standards, IP ingress protection yang
standard dia ada standard untuk dia test ke apa?
Yes.
Ini kejap, yang ni untuk yang masih waterproof lagi ke?
Yes.
Tak apalah, kalau dia ada standard and then you letaklah standard tu sebagai kamu punya target.
Okay.
Pun boleh. Dia yang penting sebab bila ada standard, dia adalah something yang memang kita boleh measure lah. So target tu dia adalah something bila kita dah siap design tu, then kita boleh test dan kita measure. Bila kita measure tu maknanya kita tahulah dia betul-betul reach ke tak kita punya target tu. Okay. Ada lagi?
Ada je. Terima kasih, Doktor.
Okay. Alright. Ada apa-apa lagi ke? Anything else regarding the HOQ and PDS? Because this one I think is very important lah. It will guide us in doing our design or our solution. And one more thing, the design specification, which I say just now, you should already, to certain extent, have it, and then you have to submit it. Okay, but after like 2 weeks from now, even until our end of the course, doesn't mean you cannot change the value of the target or even the description of your specification. If let's say from now, after 2 weeks, you think that okay, one of the specification need to be modified a little bit, then you can modify it as long as you have some good justification. Apa dia? Right. So make sure you know lah the design specification. Even though we said it here, doesn't mean we cannot change it later on. If we have a very good reason to change it, then you can change it. But whenever you change or you update your specification, you have to list down the justification and also include the time when you do the modification on the specification that is for your record. So you can see that eventually this PDS is actually dynamic. So it can be changed at the end of your design, at the end of your development. Then you will see that very likely that the design specification which you set at first and as compared to the design specification of your product at the end of the development, very likely will not be the same lah. Okay. So, ada lagi HOQ and also the PDS. Right. If no, then we continue with producing the design synthesis. We call it design synthesis. It's basically the process of doing design lah. The process of designing a system ke whatnot. Okay. In this case, actually how you conduct a design process, there are many ways lah. Depends on the designer, depends also on the engineer and so on. But in my case, I usually divide it into these 4 parts. The first part is the function. Okay, basically, we try to solve the function of the system that we want to produce or to design. Means we want to solve the workability of the system. For example, in the steering system, the function is to steer the wheel. So now, for the first question here, number 1 function, we will have to make sure how can we make the wheel be able to be steered by a driver. So we basically try to solve the function first. Okay, and then joins and support. Here basically we go into more detail once we have solved the function, and then we see how many components we have and how to connect those components together. How to connecting the components. Yeah. Ada macam ni. So basically, for the question number 2 is to solve the connection between components. Means now we go a bit detailed. Okay, so in this case, after you have completed number 1 and number 2, you should more or less get the idea already on how to improve your design. How to improve. But the improvement can be made later on. In this case, we just want to come up with one one possible solution. Okay, so after you have conducted number 1 and number 2, you should already have these two. You should already have one design or one solution lah. But please be mindful lah that this design is not yet best lah, obviously, because we just solve the function. We just try to solve the function using what our understanding of the system, and then we try to connect the components so that the function can be performed. Then we have a one design. Okay, once we have this, then you can try to generate more solution lah, more design, because here you want to improve it. And then you do analysis. In this case, from here, one design, you can go to generate more design, or you can go here, analysis. You can analyze it. In order for us to analyze, we need to have the joints and support, because the analysis really depends on the joints and support. It's a very important part lah to be finalized before we can do meaningful analysis. And then the FMA. This one designed for manufacturing and assembly. So for part number 4 here, basically we want to improve our design. We want to improve it further, so that can be assembled, can be manufactured and assembled effectively. So this is the part 1, 2, 3, and 4. Okay. Hello. Any question? Okay.
No.
We try to do one example lah, basically regarding the function. Okay, let's try. Okay, maybe we can try to do example to address the number one, the function, by focusing on powertrain system. Alright, so function of a powertrain system is what? Okay, powertrain system is basically we want to what? We want to give or to transmit power to wheel so that the car can be moved. Alright, so now this is our wheel. Let's say, okay, before that lah, I think now we try to view our car's layout from above. We should have a wheel. Okay, this is the one or the wheel that we want to drive. Means we want to give a torque here. So now you see that here the two wheels, you have to somehow connect it together because we want to rotate this wheel omega and we also want to rotate this wheel together. So they have to be connected mechanically somehow. And then from here, this is input, this is the flow, and you have your motor. In this case, motor lah. Or in a normal case, in a conventional car, is a transmission and then engine. So it's much more complex. But for an EV, even if you just have a motor, then it's already good enough. Okay, so the flow going from the motor and then split. This one I name it P lah. The power. The power is coming from the motor and then be splitted to your left and right wheel simultaneously so that the car can be moved forward or reverse lah. Okay, so now how can we do that? Okay, you can see here that the wheel, then now we try to view it from here, from front. So this is your wheel, and then this is your wheel. This is what left, and then this is right. Right kat sini. Left kat sini. Saya rasa I think I need to change this one lah to make it consistent with the figure. Right. So now you view it from in front, then you have this. Okay, now the simplest form is that this is this component which connect the wheel eventually to your tire. So the simplest form is a straight shaft. Go straight to your wheel. So when you rotate this will also be rotated lah. Okay, macam ni, shaft. But is it practical? This rotate, this also rotate. Okay. Now we need to assess it. Is it using this one? Just this one is already good enough. Okay. Now you have to make sure that in your car, eventually you will have a suspension. What does it mean? Means that your tire here can be moved up and down vertically. So what happened? If this one is connected to the motor and the motor everything is fixed, then you cannot allow the tire to move up down. If it move up down, eventually your shaft here will be broken lah. So it's not practical. We need to redesign basically our shaft here to allow this blue adjustment because of the suspension. So in this case, you need to have some modification. So I try to use green color. Okay, now you know that your tire has to be connected to a certain component here, and then you have to use something like what we call it, universal joint here. Here, universal joint. Panjang sikit. So you will need to use at least two universal joint. This one, number one, number two. And then here you have straight shaft, and then here straight shaft, one component, and then here one component. And from here only you go to this one. Okay, now with this universal joint, you allow the tire now to be moved upwards lah, axial, vertically, without interrupting the torque flow. The torque can still be transmitted right to the here lah, to the tire, even though the tire keep on moving upwards and downwards. Okay, so you solve this one. So that means your design, your complete design, your detailed design has to have this feature. Here in this case, when we want to describe function, we focus only on the function lah. So that means how we can perform it. We still don't do the complete design. So we just want to find the solution. Okay, now the solution to allow the tire to be moved outward downwards, we need to have this connection. Okay, and then here is splitting the torque from the motor to the wheel at the right and at the left. So that means here you have to use differential. Why? Because if your car is be driven straight, you have no problem, because the speed here and here should be the same. But when your car is taking a turn, turning right or turning left, the speed will be different between the right and the left. So now you need to have a differential. Differential will allow right and left tire to be rotated with a different speed. That means, okay, the motor can still transmit torque or power to the wheel left and right, even though their speed is different. So the design for the differential is quite complex lah, complex bit. So maybe we can try to find some example online. Okay. Okay, this one I think pretty much show something that you can understand. Boleh lah kot. Try to copy this. Okay, this is example of the differential. Alamak. Okay, how it works. Take a look at this one. Okay, this one, the shaft here is coming from the motor. Rotates, then your crown wheel here will be rotated. And rotate upwards lah, in this case. Okay, if this is the left lah, this is left and right. If the left and the right tire is rotated with the same speed, that means you can see that this is the something like a pinion gear. They call it a planet pinion, with the planet pinion gear here fixed with the crown wheel, so that when the crown is moving and the left and right moving the same direction, as moving with the same speed, then this one will be rotating together. This will be rotating together, and it forces left and right to be rotated with the same speed. And if the rotation of the left and right is not the same, then the pinion here, you can see that in this case, left and right same speed, the pinion, I draw it bigger here lah. The planet pinion here, this axis, you don't have any rotation. Rotation 0. Okay, meaning you have this axis, and but this axis, the pinion planet here, generally it can be rotated in this axis, the vertical axis. But if left and right wheels spinning at the same speed, it will not be rotating about the vertical axis. Just rotated, the whole thing rotated with the crown wheel at this horizontal axis. Okay, but when the speed of the left and the right is different, then here will be rotating. So might be confusing. Okay, so now in this case, rotation 0, that means left same dengan right. Okay. Lagi satu. Rotation ada value. That means left not the same as right. Okay. So that's how your differential works. So in your case, try to design this lah. That means first in this case, not to design detail, but you need to understand it, so that later on, when you want to solve the number 2 part, number 2 here, joints and support, you need to design detail. So you need to design a bit detail. But for the functions, you just need to understand, okay, you need this component to connect your motor to the right and to the left wheels. Okay, so you need differential, which somehow look like this. And then this, the differential here now connected to the motor. So you fix the motor. Okay, so that means now your powertrain, at least in terms of the function, is working. Okay, next you try to design the joints and the support to basically make your solution here more detailed. Or design. This is one solution and one design in terms of the function. So next step is to make it more detailed by including the joints and the supports. Safe. Any question? Good. Anything else regarding the how to solve the functions? Alah, saya lupa lah pula nak record. Baik dah. Okay, actually for the function, I have also recorded one lecture regarding steering system. So I think I can share it with you lah later. Patutnya saya kena record ni.
Doctor.
Ya.
For this powertrain one, it's just an example, right?
Yes, this is just an example how you can solve the function lah. Meaning how you can do design synthesis by solving the function first. That means this is just one of the solution lah. how to generate the solution or how to generate design. Doesn't mean you have to follow this one lah. This is just I show you how can you do the process step by step.
Okay, thank you.
Okay. Okay, that means the first step is to solve the function of that specific system. So this, just now I show you how to solve the function of the system that we want to design. Okay, make sure this one is just solving the function. The design, even though generally you have already generate one solution or one design, but the design here is still not complete lah. Just working in terms of the function. To make it really working, we need to make it more detailed. In this case, we have just solved part 1. We still have 3 more parts to go here. Okay. Anything else?
No, sir.
Okay, hopefully you got it. Aduh, lupa pula nak record. Question. Aduh. Ada siapa record ke? Saya terlupa lah record. Okay, anything else? I think after this I will try to record it lah. Okay, regarding the HOQ and the PDS, I want you to prepare your PDS and HOQ, and then I want you to submit it. Okay. I will give you some time. The due date for the submission I will let you know later in the WhatsApp group. And I want you to submit it using a Google form, which I will also provide the link in our WhatsApp group. Okay. Basically one submission for one SG, meaning for 3 students, one submission. Okay. What else? Nothing else?
Nothing, Doctor.
Okay, hopefully you got it. Alright. So, if nothing else, I think that's it lah for today. Hopefully you got lah your knowledge, whatever things that you need to do today. If you still have some issues that you need some clarification, you can always raise it up in our WhatsApp group, or you can contact me personally. Okay, so that means right now, I suppose you should already have, to a certain extent, your PDS. So you should also start doing your design synthesis. At least try to solve the function first. Okay. I think that's all for today. Unfortunately, I didn't record the session, so I will record it later hopefully, and then I will share with you once the video is ready. Okay, so that's all for today. Thank you for your time. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Okay, thank you. Okay. Okay, thank you.
Thank you, Doctor.